Hello. Today we're going to have a look at the area of rectangles and triangles, and then we're going to move over here to the right and have a look at composite shapes. So let's start off with just a definition of area. Now this is an informal definition. It's just that area is the space inside a 2D shape. Now area is a measurement or a unit of measurement where we can actually measure things in 2 dimensions, okay? Where previously we looked at length, and that is only a 1-dimensional measurement. So here, let's have a quick look at the units we're going to look at. So here, you can see that I have just a 1 centimeter by 1 centimeter square, and what I can do for a square is I'll multiply the two sides. So this here would be 1 centimeters squared. Okay, now over here on the right, I have the same sort of measurement. Okay, I have 1 centimeter squared, but it's actually going to be in millimeters. Okay, so I'll do 10 by 10, and that will give me 100, and it'll be millimeters squared. Okay, so our units are always going to be squared because it's in 2 dimensions. Now here I've just wrote down a few of the common measurements that we could be using. So or the conversion, so 1 centimeter squared would equal to 100 millimeters squared, and you can actually find that from what we did before. If you're ever unsure about these things, you should just draw the square, okay, and draw the measurements on the sides and do the calculation. So we have all of these ones here, but so you might want to write these down, but I will get you to note that this one over here that you might not have seen before. We have 1 HA, and this stands for hectare. Okay, and it's going to be 100 meters by 100 meters square, and that ends up being, which you can see down here, not that one, to this one here of 10,000 meters squared. So you should try and remember that too. So let's have a quick look at some of the shapes that you should have learnt last year, and it is perfectly fine if you forgot them. So in a square here, what you do is, well, it says here through the dashes in each of the sides that they're all of a side length S. So the area here will be S times S. So it's going to be S squared. And our units here, which aren't given, so we're going to write units squared. Now a rectangle here, the area, A for area, will be the length, this bottom side down the bottom, times the breadth, okay, B. So L times B, so LB. Now remember that there is an invisible multiplication sign in between there, okay, but we don't need to write it, we can just write LB. Okay, now here I've got 2 triangles, and it's very important, and I thought I would really put in this second triangle over there on the right. So here, a triangle will be the base times the height, and then we're going to divide that answer by 2. Now it's important that the height is the perpendicular height, where we have this little angle down there. Now that little box stands for a right angle, which is 90 degrees, okay? So we only times the base times the perpendicular height, okay? So which is given by that there. So here over on the right, I can see that the perpendicular height, okay, or the height with the 90-degree angle, okay, it's going to be this side here, okay? However, that's not actually a side of the triangle. But if we use that height, the same formula will apply. So I'll have A is equal to base times height, the perpendicular height, remember, divided by 2. And that will give the area of that triangle there. Okay. So you should copy these down. So you might want to take a screenshot and copy down a tiny bit after this video, or pause at the moment. Okay, I'm going to show you two sort of funny shapes, or we know them as composite shapes. And here, well, they're actually the same shape, but I'm just going to show you two strategies to find their area. So on the one on the left, I'm going to show you how to calculate the area through addition. Okay, so essentially what I could do here is I could actually split this into smaller shapes. So what I might do here is I'll cut this into a rectangle down the bottom, which I just labeled 1, and over here I'm going to have another rectangle, which I'm going to label 2. Now there are some sides that, or side lengths that I haven't put in here yet. Okay, so I look here and I see 1 dash here, so that means up the top, this is going to be 5 meters as well. And this 4 length here, well, it actually doesn't give. So what I might do is I'll subtract the 12 meters and the 5 meters. So the 5 meters plus something must be 12 meters. So this here must be 7 meters. Okay. So now that I've got measurements here, I can actually add these together. So I'm going to find the area of 1 and add it to the area of 2. So if I look at just the area of the first shape, okay, the rectangle, that has a base length of 10 and a height or breadth of 5. So I'll go 5 times 10. Okay. I have plus. Now the second shape up here is 7 and 5. So I'll times them together because it's a rectangle. And then I can put this into my calculator, or I could do it manually. So 5 times 10 is 50, plus 7 times 5 is 35. So this will be 85. Now, the units here are meters, so this will be meters squared. Okay, so that's one way to do this. Now, another way would be to look at the bigger shape and use a strategy of subtraction. So what I'm going to do on this second shape over here is I'm actually going to look at the larger rectangle. Now here, I know from the left-hand side that the bottom here is 10 meters and the overall height is 12 meters. So I'm actually going to look at this larger rectangle, which I just drew over in orange, okay, and then I'm going to subtract this section here, which I just labeled 1. Okay, so let's do this. So I'm going to have A is equal to, the area is equal to 12 times 10. And then I'm going to go minus. Well, I know this side here is from over here. I can tell that that is 5 meters. Okay, so that's 5 meters. And then we found that this was 7 meters. So that's going to be the same over here. Okay, so I'll write in 7 meters. So here I'm going to have 7 times 5. So that means that the overall shape is 12 times 10, which is 120. I'm going to minus 7 times 5, which is 35. Okay, so I have 120 minus 35, which will be 85 meters squared. And that's the same as what we got before. So that's one way to know that we did it right. So there are two separate strategies on how to handle or calculate composite shapes. And that's the shapes that are more than one shape added together. Okay, so good luck with all of your questions.